So this factoring is considered special cases. So I'm going to show you two special cases. The easiest way to do these is recognition. Can you identify just by looking at it that it's one of the two special cases? So the first one is called the perfect square trinomial. So the indicator is it's a trinomial. All right. The second indicator is they're perfect squares. So what I mean by perfect squares is it's a number that can be square rooted. Right? So 1 can be square rooted. 4, 9, 25, 36, 49, 64, 81, and 100. Okay, those are all perfect squares. Okay? So if you can identify that the first term and the last term are perfect squares, then there's a very good chance that we have a perfect square trinomial. These are the best to know how to do. It takes a little bit to identify them, but once you see, they're much easier to factor than using, for instance, you'd have to use the AC method on this. So we don't want it, we want to avoid the AC method if we can. So when we look at this, it's a trinomial, 4 is a perfect square, and 25 is a perfect square. So I'm going to trust that this is a perfect square. So I'm going to write my answer this way, set of parentheses and the whole thing squared. Okay, so here's what we do. Take the first term and we square root it. In other words, what times what, and it's got to be the same thing, what times what gives you 4x squared? Well, 2x times 2x gives you 4x squared. What times what gives you 25? The square root of 25 is 5. I'm going to use this first symbol. So if this is a minus sign, I'm going to use it. If it's a plus sign, I'm going to use it. I can forget about the last sign. It's just this first sign that I use. So now how do I know for sure if it's a perfect square trinomial? Well, a perfect square trinomial means if I multiply these two, so 2x times negative 5, I'm going to get negative 10x. If I can double that and I get this middle term, it's a perfect square trinomial. So 2x times negative 5 is negative 10x doubled gives me, or times 2, negative 10 times 2 is negative 20. There it is. I'm good to go. Okay? How about this one? My pens are starting to dry out. Okay, so it's a trinomial. I'm good. 36 is a perfect square because 6 times 6. 49 is a perfect square because 7 times 7. So I'm going to put my set of parentheses squared. Square root of 36x squared is 6x. Square root of 49 is 7. I'm going to use this first sign. So I have 6x plus 7. If I can multiply this and double it and get this middle number, I know I have a perfect square trinomial. 6 times 7 is 42. 42 times 2 is 84. I know I have a perfect square trinomial. Okay, so square root, multiply and double should give you that middle term. You're good to go. That's factoring. It's just an identity. The next one is called the difference of two squares. So that's our second type of special case. So difference indicates a subtraction problem of two perfect squares. So this one should really be set apart from all the other ones because you have only two terms. It's a binomial. Okay, so an example would be x squared minus 25. So it's two perfect squares. Difference means it's a subtraction sign. So this will not work if there's a plus sign in between. It has to be a subtraction sign. So when you see difference of two squares, you set up your two sets of parentheses, square root the first one, so x and x, square root the last one, 5 and 5, 1 is plus, 1 is minus, and you're done. Okay? Find the square root, 1's plus 1 minus, you're good. So let's try another one. So we have 4x squared minus 49. Perfect square, there's a minus sign in between. I have difference of two squares. So two sets of parentheses. What times what gives me 4x squared? And it's got to be the same thing, so that goes in the first position. What times what gives me 49? That goes in the second position. One's plus, one's minus, and you're good to go. And I hope you can see that. Okay, that's it. That's all the factoring.